Find the interval of convergence for the series 1 minus x by 2 plus x square by 3 minus x cube by 4 plus etc. In order to find out the nth general term for the given series, notice that positive negative signs occur alternatively, and whenever the power of x is odd, we have a negative sign associated with the corresponding term. If you consider n is the general denominator, then this denominator and the power of x is so related that when n is the denominator, the power of x will be n minus 1. From these observations, we have the general nth term possible for the given series will be u suffix n equals x raised to n minus 1 upon n multiplied to minus 1 the whole raised to n minus 1. We have radius of convergence will be capital R equals limit n tends to infinity un by un plus 1. But here we are asked to find out the interval of convergence directly. However, in this question, we will find out radius of convergence looking at the interval of convergence as an additional exercise. In order to find out the interval of convergence, we will depend on ratio test. By ratio test, first we will have to evaluate limit n tends to infinity un by un plus 1. We have modulus un equals modulus x raised to n minus 1 upon n. And here when you replace n by n plus 1, you will obtain modulus un plus 1 equals x raised to n plus 1 minus 1 upon n plus 1. Thus, you obtain absolute value of un plus 1 will be this expression. When you evaluate modulus un upon modulus un plus 1, after simplification you get this is equal to 1 by x multiplied to 1 plus 1 by n. When you give limit n tends to infinity to modulus of un by un plus 1, you obtain limit n tends to infinity applied to this term multiplied to limit n tends to infinity applied to this term. When you give limit n tends to infinity to the term 1 plus 1 by n, it becomes 1. This is because limit n tends to infinity 1 by n equals 0, and therefore limit n tends to infinity 1 plus 1 by n will be equal to 1 plus 0, which equals 1. Limit n tends to infinity has no effect for this term because this term is independent of n. Therefore, we have limit n tends to infinity modulus of un by un plus 1 will be equal to 1 by modulus x, and by ratio test, whenever this limiting value happens to be greater than 1, the corresponding series will be convergent. Therefore, in order to find out interval of convergence, we will think about the situation wherein this limiting value 1 by modulus of x happens to be strictly greater than 1. This happens only when modulus of x is less than 1. We have these two inequalities are exactly the same. It is in this situation that the given series will remain convergent. That is, for modulus of x greater than 1, the given series will be divergent. Now we will analyze the nature of the series at the endpoints, that is at x equals 1 and at x equals minus 1. When you consider modulus of x equals 1, the two possible values are x equals 1 and x equals minus 1, which are the endpoints of the interval to be examined. At x equals 1, this series will become 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. At x equals minus 1, this given series will become 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus etc. At x equals 1, we obtain an alternating series with alternate plus minus signs. In order to check whether this alternating series is convergent, we will have to depend on Leibniz test. As per Leibniz test, which gives us information on whether the alternating series is convergent or not, the necessary condition for the alternating series to be convergent is that first condition, absolute value of un is strictly greater than absolute value of un plus 1, and the second condition will be limit n tends to infinity applied on nth general term will give 0 as the answer. Here we have 1 is strictly greater than the absolute value of 1 by 2. 1 by 2 is strictly greater than the absolute value of 1 by 3. 1 by 3 is strictly greater than the absolute value of 1 by 4, and so on. We are neglecting the signs and we are just taking the absolute values of each terms, and it follows the first condition that any nth term has a numerical value which happens to be strictly greater than the succeeding term or the succeeding term's numerical value, and therefore the first condition is satisfied. For this alternating series, you can consider the nth general term u suffix n will be equal to 1 by n. When you give limit n tends to infinity to 1 by n, you are obtaining 0 as the answer. Therefore, Both the necessary conditions are satisfied, and this ensures that by Leibniz test, the considered alternating series will be surely convergent. Therefore, we have concluded that at x equals 1, the given series will be convergent. At x equals minus 1, we obtained this series, which is of the form summation 1 by n raised to p, where p equals 1. You can consider this series as summation 1 by n, which can be considered as summation 1 by n raised to 1, where the power of n p equals 1. By p test, we have whenever p is strictly greater than 1, summation 1 by n raised to p will be convergent. Here we have obtained a series which is of the form summation 1 by n raised to p, where p equals 1. Since p is equal to 1, and by p test, whenever the power of n p happens to be less than or equal to 1, the corresponding series will be divergent. Therefore, since this series is a divergent series, we have the given series will be divergent for x equals minus 1. Therefore, the interval of convergence for the given series will be open minus 1, comma, closed 1. That is, set of all x values or set of all real values lying in the interval open minus 1, comma, closed 1 will be the interval of convergence. When you consider the endpoints of the interval as minus 1, 1 and 0 as the central point, you have from 0 to travel to reach the endpoints either minus 1 or 1. You have to travel a distance capital R equals 1 units, and therefore the radius of convergence for this interval of convergence will be equal to 1, which will be equal to the radius of convergence of the given series. Geometrical interpretation will be when you consider x0 minus r, x0 plus r is the interval of convergence which is centered at x0. The distance from the center to either of the endpoints of this interval will be the radius of convergence.